So fine. So this is the video for solving the problem of the day in on Leetcode, which is basically this one. Count the number of bad pairs. Yeah. So what we need to do in this is that you are given a zero indexed integer array nums and a pair of indices I, j, and is a pair bad pair if I is less than j and nums j minus I is not equal to nums j minus nums I. So total number of bad pairs we need to return. Okay, where j is greater than I and j minus I, the difference in indices is not equal to the difference in the values here. Okay, so we are given that for any two values of the array, let's say one is here, one is here, this is j and this is I. Okay, so j minus I is not equal to the value at the j and I. Okay, fine. So see, for this to happen we need to find such pairs, right? So just think of something that here, what are the total number of pairs when we are given n numbers? We know that the formula for the total number of pairs when n numbers are given is this. N into n minus 1 by 2 is the total number of pairs, right? And out of this total number of pairs, some will be bad pairs and some will be remaining will be good pairs. So if we find the good pairs, the bad pairs will be what? Total minus good pairs, or vice versa, correct? But we need to find the bad ones, so let's try to focus on the good ones. Okay, that's just a way to find this. So let's just try to focus on the good ones. And what are the good ones? If bad ones are these, good ones will be where j minus I is equal to nums of j minus nums of I, correct? This will be the good pair. So if we rearrange this means that nums of j minus j is equal to nums of I minus I, correct? We just put it this side and this one, this j this side, correct? So we got this equation that for two indexes where j is greater than I, the difference between a number and the index, it must be equal. If they are equal, it's a good pair. So what we can see here is that for the whole array, okay, for the whole array, we are at this index, then or in any of the future indexes we are at I. Okay, let's say this term is defined as nums of I minus I for any term is defined as, let's say, value x. Okay, if this x value is repeated in future again for any index, like for any index to the right of I, if we again get the same value of x for the difference of number and the index, means it forms a good pair. Let's say when we reach here, we again get a value of x for ni minus I, means this index and this index forms a good pair, right? This index and this index forms a good pair because they're in because they hold this true, that they have this value equal, and j minus j is equal to ni minus I, which holds for a good pair. Okay, so it's a good pair. So we just need to iterate through the array and maintain a counter value basically for all the differences of indexes and values. So we can maintain a map for that. In the map we will store the difference, and whenever we will again get that difference, if that difference existed earlier, that means it forms a good pair. Now let's say the example is this one. This is the given array. What will be the indexes of them? 0, 1, 2, 3. What will be the differences? This will be 3, this will be 0, this will be 0, and this will be 1, correct? So how many good pairs are there? We are at 3. No pairs can be formed here. We are at 0. No, no good pair. We are at here. Now when we are at 0, we got value 0. We store it in the map that we have got a value 0. 0 has a counter of 1. Again we got a 0. Fine. When we again get a value 0, we will see if this value exists in the map and it has a counter greater than 0. Yes, it has. Then we will increment the number of good pairs by that value. So good pairs now becomes 1 and 0 will become now. The counter will become 2. Okay, now we go for here 1. 1 is nowhere in the found to be found in the map earlier. So number of good pairs are 1 and number of total pairs are 3 into 4, 4 into 3 by 2 means 6 are the total pairs where 1 is good, so number of bad pairs are 5. And even if we calculate it, we can just see that 3 and 1 forms a bad pair, 3 and 2 forms a bad pair. These are the two bad pairs. Then again 1 and 4 forms a bad pair, 2 and 4 forms a bad pair, 4 and 3 forms a bad pair. So 1, 2, 3, 4 and 5 bad pairs are there. It's just that one pair is good, which is 1 and 2, because they both have the same value for the difference of their index and their value. So this is what a good pair looks like. So this is how we can do this question. We can firstly just write n as the size of the array. Fine. Now we can calculate the total pairs possible here. So it will be n times of n minus 1 by 2. Correct. We got the total, we got the n. Now let's have a unordered map. It will be int to int, and let's say this mp. Okay, now we will go through this array, iterate through this array and do what is each time. Let's say we define a value of x as nums I minus I. Fine. And we will do what is, let's say we have a variable here, good pairs, as 0 initially. Okay, now we will see that good plus equals to will be if this value has appeared earlier in the map. Correct. And then we will increment the map that it has appeared again. So the answer will be like total minus the number of good pairs. That will give us the bad pairs. Correct. So let's just run it. Yeah, and it's correct. Okay, something is bad here, which is that it overflows. Okay, let's do this then, and let's do the same thing for the counter also. Okay, use this test case and now run it. Again it overflew. So int in total is equal to n into n minus 1 by 2. And how does it yeah, because the concept is right, it's just that the time signed integer overflow cannot be represented in type int. Okay, fine. So we haven't defined it as int. Runtime signed integer overflow, this cannot be represented in type int. Line number 5. So n into n minus 1 by 2. Why is it int? Because we defined as long n. So let's do this also. Let's just try to do this. Okay, this works fine now. Yeah, most probably, not just most probably, it's surely because of that issue that now what's that? The output comes out to be this, and we have expected a zero output. And why is it? Okay, it's a long input where 1, 2, 3, 4, 5, 6. Okay, and it reaches out of the bounds, most probably. Correct. It reaches out of the bound. So let's just replace all the ends by long long. Yeah, actually we need to do this because if you see the return type of this function is long long, so the range covers more than the end, so we need to use long long everywhere uh, to maintain this. Yeah, it works. So the earlier issue was because of we are multiplying two integers n and n minus 1, and they will give an integer, and we cannot store it in the long long. So basically we need to make this as also long long so that the result will be long long, and also the return type is long long. Okay, and good was int, so that's why the error was happening, that at some point it overflew for the integer and gave us the result right there. So it was not zero, because if we see the last test case was just consecutive numbers. So yeah, this was a pretty easy question. So this is our day 2 streak, and we'll be doing this daily again along with our daily series. We'll be also doing this. So that's all for today's question of the day.